All right now we're going to pick up where we left off. And we started talking about Java data types. And today we're going to talk about the primitive data types. So our primitives, as you recall, consist of 8 types: boolean and char. Those are the 2 non-number types. The rest are the number types. And what we're going to do is we're going to do a few exercises involving primitives. All right. So now let's do a few simple exercises involving primitive numbers. That may seem fairly mundane, but trust me, sometimes it's the little things that matter. And in order to get good at the bigger things, you gotta master the little things. So let's start with exercise number 1. So, okay, favorite numbers, favorite number. So we're gonna store our favorite number in an int. So, so let's do that. So we can just declare a variable int. So you start with the type and then favorite number. And I'm going to say it's 1 because sometimes I just want to be number 1. But right now, I'm just the one that's teaching Java data types. So we just stored this number in it, and this is an assignment operator. It's an equal sign, but it's an assignment operator. So again, it's those little things. So this assignment operator assigns the value of 1 to this variable favorite number. Now, using that variable, create a message that reveals your favorite number, okay, and display that message. For example, my favorite number is 99. So we'll do a sysout. So type SYSO, then control space, and that's how you get your sysout. Your system.out.println. So my favorite number is, and then this addition operator, it allows us to concatenate this string, favorite number. All right, we'll save this and we'll run it. My favorite number is 1 because, like I said before, I am the one teaching data types today. Okay. All right, so let's comment this out and move on to something else. So add in integers. So create 2 int variables. One should store the number 5, and the other should store the number 3. So int first num equals 5. And notice in Java, you need semicolons. If you don't put a semicolon, it's going to give you an error. Syntax error, insert semicolon to complete block statements. So let's insert this semicolon so that we can complete this block statement. And this squiggly line means this variable has not been used yet. Okay, so int num2 equals 3, and display the value of the 2 variables added together. All right, let's run this thing. Okay, so the value together is 8. All right, we're done with this. Let's keep going. Let's go. Okay, create an int variable called counter, give it the value of 0. Now do the following. So yeah, this is a real life example of some of the stuff you're going to do. Many of the loops that you're going to run in programming will involve keeping track of a counter variable. So int counter equals 0. So it's assigned to 0. So increment counter. So we're going to use the increment operator. So increment counter, then add 5 to counter, decrement counter. subtract 2 from counter, double the counter's value, display the value of the counter. Okay, so seems like a lot to do, but not really. So increment counter, so increases value by 1. So there are 2 ways to do this. So you could do counter equals counter plus 1, and it will increment the number of the counter. But a cooler way to do this is just to use the plus plus. So we do plus plus, and I'll give you 1. So we'll just sys out real quick. Counter. It should give you the number 1. If we do it the other way, it'll give you the number 1. So let's try something else. So let's comment out this. While we're here, I want to show you a trick. So what do you think is going to happen if you postfix this operator? Okay. So it prints 0 because what it does, this system.out.println, it reads this counter value first, which is 0. So it prints it, then it increments the value. So if we do this again, let's run it. Now it prints 1, okay? I only talk about this because this stuff actually does come up from job interviews, maybe not any of my job interviews, but I'm sure it's come up with in somebody's job interview. So now we're using this as a prefix. So let's guess what this is going to print. Is it going to print 0 or is it going to print 1? So it prints 1. Let me tell you why. It's because it performed the addition operation first. Then it printed the counter. So operations work from left to right, okay? And let's see what happens if we print the counter value again, and no shocker, it's going to print 1 because it already did its calculation. Okay, so enough of this. Let's get back to the problem at hand. I just want to add up these numbers quick and move on to other things. Okay, add 5 to the counter. Again, you can add count. You can do the counter equals counter plus 5, and I'll do the same thing. But again, I got another cool way to do it. I wouldn't say cool. It looks cool, but it's just another way of doing things. Okay? Because one thing you got to remember in programming, something may look cool, but it doesn't mean it's the best solution. So we got counter plus equals 5. Okay? So this will also add 5. So this is a plus. So it adds, and then it adds the value. So it adds and assigns the value of counter plus 5. Okay, decrement the counter. You can also do the same thing. So decrement it by 1. So counter minus minus. Okay, it's similar to plus plus, except it decreases by 1. Okay. And you're kind of wondering, why not just add 1? You can. Why not just subtract 1? You can. But this looks a little more readable for some people. And then we can subtract 2 from counter. Minus equals 2. Double the counter value. So you could do it like this times 2. But as you guessed, there's another cool way to do it. Another kick-ass way to do it. So we'll just do times equals. Okay, and then we display the value of the counter. Okay, let's see if we did this right. Okay, we got 6. So what we did is we added 1, so the counter is 1. We added 5, so it's 6. We subtracted 1, so it's down to 5. Subtracted 2, down to 3. Six. Now it's 5. Now we're subtracting 2, so it's down to 3, multiplying by 2, so it's 6. So that's how we get our 6. All right. So we're done here. Let's keep moving. Because like I said, this may not look like exciting stuff, but you gotta master the fundamentals. You gotta master the fundamentals. Okay. So let's look at this. So I'm just going to go through the motions and then we'll discuss things on the way. So different ints. So create the following int variables, a with a value of 5, b with a value of 2. So int a equals 5, int b equals 2, assigned to the value of 2. Then display the values of the following. A divided by b, so a divided by b. And then I'm just gonna keep copying and pasting. Because unlike in the movies, us programmers in the real world don't type that fast. So the second one will be C divided by D. And then whatchamacallit, C divided by D. There's one more. A divided by D. Okay. Oh, and another thing is I forgot to create the double variables. All right. Int C, and it's not int, it's double. And doubles are decimals. It's 5, but it's technically 5.0. And that decimal is important. Equals 2. Okay. So notice that A and C both have the value of 5 assigned, but the way it is stored is different. B and D have the value of 2 assigned. The way that is stored is different. So let's see what happens. What's going to happen here? Ooh, I'm so excited. Okay. Then this, okay. So this 0, yeah, that's not part of, okay. So let's comment this out. Run it again. Eliminate confusion. Okay. That pop-up just told me I didn't save my work before trying to run it. Okay. So notice that A divided by B, this first one, it's 2. So notice that it's not 2.5 because you are dividing two ints. So you're casting. So this is being, so the result is casted to an int. Okay? Because you're dividing two ints. So your result's going to be an int. Okay? Because whenever you're casting, it's going to tend to cast to whatever data type holds more memory. Okay? And then C divided by D. So C divided by D, both are doubles, so you're going to get a double. So you're going to get a 2.5. So notice here there's some data loss, which is why in Java you have to pay attention to your data types. Okay, C divided by B. C is a double, B is an int, but the answer is going to be cast to a double. A is an int, D is a double. Again, the answer is going to be cast to a double. Okay, so I hope that's clear. I hope that's clear. So be careful of that. Okay, now we're going to move on to characters, our non-number primitive type. So let's see what they're asking. So create a char called letter, give it a value of A. So char of letter, and we're going to give it a value of A. Now notice that char types, you have to wrap in single quotes. If you put it in double quote, it's not a char, it's not a primitive anymore, it's a string. All right, create an int called code and give it the value of 98. Okay. Display the value of the letter variable cast to an int. So we're going to do our sysout. So display the value of the letter variable cast to an int. So the way you cast is the casting operator are just two parentheses. So int, so you're going to cast an int, and you're going to cast the letter variable. Okay. What I'll do is I'm going to put this in a variable for clarity. So we're going to call this, so we know we're casting to an int. So we're just going to call this casted letter, because whenever you're naming your variables, they should be descriptive, and they should be in camel case or dromedary case for some of the geeks out there. And they should be descriptive. So casted letter, we're just going to call this int letter. And then we're just going to print this. Okay. Let's see what we get. Okay, so we do get 97. So what this is doing is it's casting this letter, this A to an int. So it's printing the Unicode value, the integer value of this letter here. Okay. The next thing it says is display the value of the code variable cast to a char. So code is 98. So we're just going to call this casted code equals char code. Okay. So we'll print this as well. Let's comment this out. So in order to comment things out, just control / comment some things out. All right, let's save it and let's run it. And this is casted code, not casted letter. All right, let's run this thing. Okay, and we got B. So and it makes sense because if you cast this int to a letter, if you cast this letter A to a letter and get 97, okay, what comes after 97? 98. So you're taking this 98, which comes after 97, and you're getting B. So using my pattern recognition skills, this makes perfect sense. All right. So let's comment this out as well. Okay. And we'll display the number 36 cast to a char. So, and I'm just gonna do the casting operator. So char 36. You can just cast 36. And let's see what we get. Oh yeah, we got a dollar sign right here. So yeah. So we got a dollar sign. Okay, that's great. We can convert numbers to letters and letters to numbers. It's a wonderful thing. Okay, let's move on. So the difference between letters. So the difference between two letters, two characters is going to be the difference between their Unicode values. So, so we'll just do a sys out. C minus A. And let's do the other one too. Z minus A. And so C minus A, it's going to be 2. And I can tell you why, because C is 2 places ahead of A. Z is 25 places ahead of A. So this all makes sense, actually, when you think about it. Okay. All right. So let's move on. So we're going to add characters and strings. So we'll create 3 characters and give them the values X, Y, and Z respectively. We'll create 2 strings, and we'll talk about strings later, and give them the values Z and Y respectively. Okay. So char1 equals X. So char2 equals Y. Char3 equals Z. All right. And then we'll create 2 strings. So string 1 equals Z. So notice there's a difference. So double quotes, string, single quotes, char. This equals Y. Okay. And then we'll display the following. So we're gonna have 3 sysout statements. Okay. Okay. Let's see what we're going to get here. Let's see. So you would think char1 plus char2 plus char3 is going to give you X, Y, and Z, right? And you would think that char1 plus char2 plus string Let's see what we get. Okay. So it gave us a value of 363 because it added the Unicode values. Okay. Added the Unicode values. And that's the thing, when you add two characters in succession, then it adds the Unicode values. So let's change this up a little bit. So let's uh let's put string one plus char three. Okay. And we'll do string two plus char three. And let's see what we get now. And then this we'll just comment this out because we know that's not good. We know that it's going to give us 363. So let's see what we get. And of course, you got to save it. Okay, so xzz, which is what we expect to get, and xyz. And let me tell you why. Because as long as you add a string, if you have a string and you add a character after it, it's going to give you a new string. So it's going to instantiate a new string. It's going to create a new string. But the problem is when you add two chars in a row, then it's going to add the Unicode values. So the best thing is if you want to get a string, don't add two chars in a row. All right. I think we're done with primitives. So I'm just going to stop at this point. And until next time, peace.